So you'll be talking hopefully about ionization energies in your other lessons, I hope. Okay, what does ionization energy mean? Well, ionization energy, let's say I'm doing it for sodium, it would be taking sodium in the gaseous state and making Na plus in the gaseous state plus an electron. Yeah, that would be called the first ionization energy of sodium. We are going to look at the trends in the first ionization energy across the periods. So we're going to look at this value. So this has a certain energy. We're going to look at how this value changes as I go across each period. So we should be able to predict this. Let's draw a little sketch graph. So we're going to have along here, we're going to plot first ionization energy. What would I measure ionization energy in kilojoules per mole? And along here, I'm going to have atomic number. So we're going to start here. I'm not going to worry too much about numbers, but I'm going to put key ones on. So my first one, I'm going to start as being hydrogen. Helium is going to go up like so. My next one is lithium. So lithium is going to go down here. Lithium, notice, is, I'm going to make that a little bit lower. If I go all the way down, lithium is below hydrogen. So you've got hydrogen, helium, and then you're going to go all the way down to lithium. I then go up to beryllium. I then have a little bit down to boron. Not big, just a little dip. Then it goes up again to carbon, and then up again to nitrogen, like so. A little pop down to oxygen.
What's the second one? Sorry, I can't see.
Oh, that's helium. That guy there. So I've gone a little bit down. Then I'm going to go up to fluorine. And then I'm going to go to neon. Can you make sure that the dot for neon is below that for helium? So helium should be higher than neon. There. I'm then going to have a mega drop all the way down to sodium. Sodium should be below lithium. And then I'm going to follow the same, I'm going to go up to magnesium. Down a little bit to aluminium. And then up for silicon, up for phosphorus, down for sulfur, up for chlorine, and then up again for argon. Now, I'm going to point out some key things. You do have this, so I just want to point out some key things that you need to be aware of. Okay, so everybody can watch. helium to neon to argon should be going down. So that is going downwards. These are all lower. In a similar way, you've got lithium and sodium going down. Like so. So going from helium to neon to argon, you see a decrease in first ionization energy. And you also see that, for all the groups. Now going across one period, what happens as I go across period one? Generally, as I go across period one, my first ionization energy across it is going to increase. Across a period, first ionization energy increases. So that was period 2. What about period 3? Do I see the same trend? Yep, also across period 3, first ionization energy increases. Okay. So we're going to do down a group. Down a group, if you look at all these groups, even fluorine to chlorine, oxygen to sulfur, nitrogen to phosphorus, it's decreasing. So why does it decrease down a group? So down a group, first ionization energy, i.e. for ionization energy, decreases. So that's the trend that we see. The increase in nuclear charge, because we have more protons in our nucleus, so though we have more protons in our nucleus, we have an increase in nuclear charge, is cancelled out by the increase in shielding and the outermost electron is further away from the nucleus. Which reduces the attraction between the nucleus and outermost electron, making it easier to remove. Now I know it's really wordy, but you have to cover all those angles. You need to comment. Although the nuclear charge is increasing, it's far more important that you've got more shielding electrons and the outermost electron is further away from the nucleus. This reduces the attraction, making it easier to remove. If we just go into shielding, remember helium, if I draw on helium, helium has just got its 2 electrons in its first shell. Neon, however, has got those 2 electrons and then 8 electrons. And then argon has got a whole nother shell. Like so. But each of these, for the first ionization energy, I'm removing that electron, that electron, that electron. So it's much easier to remove that electron, because although argon's got more protons, he's got a whopping 18 protons. Neon's got 10 protons, helium's only got 2 protons. So he's got more protons. However, this electron is further away from those lovely positive protons. He's got more shielded electrons. This guy has got 10 shielded electrons. He's only got 2. Remember, the shielded electrons are the one between the nucleus and the outermost electrons. Have you talked a little bit about shielding? Why do they shield? If you think about why don't these guys shield? Why don't I worry about those? Well, if you think about, if you're at a party, if you think these are like the attractive boys here, and this is you here, these people are getting in your way. So they're the ones that are stopping you from seeing the boys there. They're like, get out of the way, you're shielding me from the boys. These, your mates, that you're just chatting with, next to them, they're not getting away. You've still got a nice view of the attractive boys over there. So they are shielded. These guys aren't affecting your pulling power. They can still see you. It's these guys that get in your way and stop the attraction from happening. So think of it that way. Let's have a think now. What's happening across a period? So I have taken this period here, my second period, and I've just drawn the electronic structure of 3. I'm going to start with lithium, and we're going to work across neon. You have to consider 3 factors always. You always talk about nuclear charge, you talk about shielding, and distance from the nucleus. So, let's go for this. Nuclear charge. What's happening to my nuclear charge as I go across? Increasing. Brilliant. So my nuclear charge is increasing. What is happening to the number of shielding electrons?
The same.
Brilliant. Show the same. 2 there, 2 there, 2 there. So shielding electron stays the same. The final thing, what happens to the distance between the outermost electron and the nucleus? What do you think is going to happen to that outermost shell? Nuclear charge is increasing, but shielding stays the same. It's going to pull the atom in. Yeah, the atomic size is going to get smaller. It's going to pull that outer shell in. So my 3 things: nuclear charge goes up, shielding the same. Distance between these guys and the nucleus is going to decrease. So that quite nicely, I think, explains why across a period my first ionization energy goes up. So always talk about those things. So let's go through this. So across a period, the first ionization energy increases because nuclear charge increases. I've got more protons in my nucleus. The number of shielding electrons stays the same. The distance between the outermost electron and nucleus decreases. And these 3 things result, therefore, the outermost electron is more attracted to the nucleus. And more energy is required to remove it. Now I know it's very wordy, but in your mind just think, always talk, trend. 3 things: nuclear charge, shielding, distance, and then wrap it all up by talking about the attraction between the nucleus and the electrons, and that will get you the marks.